Done. Okay, so in terms of the key learning intentions for kinematics and motion, we're interested in that particular equation. That's the very simplest and first equation. There's 6 equations that we're working with. But what is distance and displacement? How are they different? What are speed and velocity? How are they different? Acceleration and force come in. What about units and unit conversions? How do we get from meters per second to kilometers per hour? And you'll notice we use the -1 instead of kilometers / hour. And we'll talk about that today. Scalar versus vector measurements. Motion definitions, and we have some of these keywords down here, and how to use simple equations. So those are all of the things we're interested in. You don't need to write those down. Those are the key learning intentions. Now, we've already had a look at that. The kinematics is the branch of mechanics concerned with motion of objects without reference to forces which cause motion. You don't need to remember that definition, but we're interested in how things move and how they move relative to each other. We're on a big old ball, I suppose, moving through space. We're rotating at I forgot how many thousands of kilometres per hour. We're rotating, and then we're orbiting the sun at an incredible velocity, and the sun is orbiting the galactic centre at an even greater velocity. So everything's moving relative to each other. Okay. The reason why I put this here, this idea here, is we'll be working with force diagrams later. So you've seen the rocket launch, and so you have the force of gravity pushing down, or it's better to think of that in terms of weight pushing down, because weight is gravity times mass. Okay, and then the force of the rocket motor is pushing the rocket up. And if the arrows are the same size, what does that mean in terms of movement? If the arrows are the same size, yeah, there isn't any movement. It's like tug of war, where the force of the opposing teams is exactly equal to each other. There is no movement. Okay, so when you do your diagrams, you'll need to show with the length of those arrows which forces are greater. So, for example, this is friction on the road, and this is a skateboarder moving forward. Now, if the skateboarder is, well, in this case, again, it would probably be better to have the arrow longer here in terms of if the skateboarder is trying to push off, that arrow would need to be longer. The force would need to be greater than the friction, otherwise there wouldn't be any movement. Now, there we go. There's our 2 mini little definitions, and those are the ones you'll need to note down. Distance is the measurement of an actual path travelled. So the distance is the road, if you like, that the motorcyclist takes. Displacement is the straight line distance between 2 points. Okay, so, and it can have directionality as part of that. So the displacement of the motorcyclist in this picture, simple question, is how far? 120 metres. Yeah, that's the straight line distance from the house to the factory. I'm not sure why it's taking the motorcycle, but okay. It's 120 metres distance versus that's the displacement. The distance is 200 metres. Now, what distance does the rider travel? The distance the rider travels on his way to work is 200 metres. What is the rider's displacement? Done that already. 120 metres. At the end of the day, when the rider returns home, what is his total displacement for the day?
Wait, no, 0. It's 0.
You are correct. It is 0. This is his starting point, and at the end of the day, how far from that starting point is he? 0 metres.
He works overtime.
So displacement, and that's the key difference. The distance that the person travelled in the day would be considered to be 400 metres, but his displacement would be considered to be 0, because actual metres from home is 0 if he's standing at home. The question that typically comes up in tests and exams is you'll have someone running a 400 metre race. So the 400 metres, the start line and the finish line are the same, and you run 1 lap. And what distance did the person travel in the race? 400 metres. What is the displacement of the person at the end of the race? 0 metres. even though they ran a lap, they have returned to where they left from. Okay, so that's a key difference between displacement and distance. Now, speed is measured in metres per second or kilometres per hour. Now, that one there, you're probably more used to seeing things like this. Metres per second, yes, and kilometres per hour, but in Year 10 physics we use the -1 designation. Metres per second, really that means metres over seconds, yeah? Do you understand? That backslash means metres divided by seconds. And this actually here also means anything to the power of a -1 is actually seconds with 1 over the top. And so it's metres times 1 divided by seconds, which is the same as this. So we end up in this, we use this configuration, metres per second and kilometres per hour. The same units are used for velocity. So if you see those units in a question, what are we talking about? We're talking about velocity. The difference between speed and velocity seems minor, and it is. How fast an object is moving over a distance, speed in a particular direction. That's the key difference. So velocity should have a measure of directionality included. So 20 kilometres an hour north, or 20 kilometres an hour left, or 20 kilometres an hour forward, I suppose, in its simplest form. Whereas speed is just how fast an object moves, but the units are the same. The formula for calculating velocity is x, displacement, over time, whereas the formula for speed is distance over time. You probably remember that one. I've given you the magic triangle. Does everyone know how to use the magic triangle? You want to draw the magic triangle down if you're not very good at manipulating equations. If V, so V here is, hang on, did I get that wrong? I think I've done a typo. I have. Naughty. I made that this morning and I wasn't paying attention, careful enough attention. So don't copy the triangle just yet. See, those two right there are in the wrong positions. Silly. Let's fix that up. So apologies if you've already drawn the triangle. Not the end of the world, but just a bit annoying. Okay, done. Done, fixed. So, in this case, V, if we're after V, it's equal to x over t. If we're after x, what is the equation for x? X is equal to V multiplied by t. There's a multiplication there. And if we're after t, it's equal to x divided by v. So that's how you can use that triangle, xvt triangle, to try and, if not remember the formulas, at least work out how to derive the formulas. So in every exam, physics exam and test, you're usually allowed to take a formula sheet in. But this year's curriculum is changing, so we're having a meeting on Friday to determine exactly what's going to happen there. So in previous years, I would have already handed out the formula sheet, and it was pretty extensive. But in this year's case, I'm not even sure if you're going to get that. So I'm going to give you that little triangle to try and help you, and we'll go from there. Now, let's see. Average velocity is calculated by dividing displacement travelled by the time taken. So this gives you the average velocity. So I'm only able to, if I drive to Melbourne, going through Bendigo, I'll be doing 50, I'll be doing 60, I'll get to 80, the 80 zone, then I'll get to the 100 zone, and it might take me an hour and a half to get to Melbourne. But all of those velocity changes are averaged out. You only get my average speed. If I get 100 kilometres down the road and it's taken me an hour to get there, then my average velocity is 100 kilometres per hour. Okay, I might have done 120 sometimes and 80 at other times, but it took me 60 minutes to cover that distance, so I've got an average velocity. So you have to be careful with that. Now, is everyone finished there? Where, who, why? You might have, we can come back to it. Okay, now, when we do calculations, there's a certain method you should follow when you have questions given to you. So, fill in the variables you know and put a question mark for the unknown, and that tells you what you're looking for. For step one, make sure you include the units when you're writing things down. Okay? Fill in the equations, make sure you include the units, show working. You don't need to write those down. You need to be conscious of them. Let's do this problem, and then there's another one down here. Okay, if Brian runs 100 metres, 100 metres, metres is a measure of what? We'll say displacement. We'll get into that idea, and that's the x value. In 9.6 seconds, seconds is a measure of what? Time. So that's our t value. So I've got given x and t. What is his velocity? Well, that's pretty easy. That's v equals question mark. So we're trying to find velocity. What formula do I use to find velocity? V is equal to x divided by t. Now, key point here. Physics is interesting for students in assessments because at the start of the physics test and the start of the physics section of the paper, it will say showed full working. Now the marks might be worth, each question might be worth 3 or 4 marks. If you show no working and get the answer wrong, you get 0. If you show working and get the answer wrong, you might get 2 out of 3 or 3 out of 4 because it's consequentially graded. So usually it's 1 mark for the formula. V equals x over t. Great. Let's fill in our values. Only 1 equals per line. X is 100 metres. Don't forget the unit. T is 9.6 seconds. Right? Now, if I was silly and put 1,000 metres down by accident, I'm going to get the wrong answer. No doubt. I'm just going to get the wrong answer. So I'd lose a mark for that. But because I got that right, and because the answer of my calculation was correct for these numbers, I'd get a mark for that as well. So I'd be given 2 marks out of 3, even though my answer was quite wrong. But if you just put the number down, you get 0 if it's wrong. So you need to show full working. You also, I'll emphasise this now, need calculators. A scientific calculator. You can't use the large programmable Casios. You won't be allowed to use them in the test. You won't be allowed to use them in the exam because they're programmable. You could hide information on them and for genetics or other topics. So you're just not allowed to use them. You need a scientific calculator. You're not allowed to use a phone. Don't borrow a friend's calculator for the exam. This happened to me last year. It's happened to me every year. Students put up their hands. I don't know how to use this calculator. My job as an invigilator is to invigilate. I'm not actually allowed to help you learn how to use a calculator. You just borrowed 2 minutes before the exam. Go to Big W or somewhere, get yourself a $7 scientific calculator. That's what you need to use. And you need to learn how to use it over the next 2 weeks, not just 2 minutes before the test. Okay? 100, what's 100 divided by 9.6? Quick calculators. 100 divided by 9.6. If you don't have a calculator, shame on you. 10.41. Ah, well done if you gave me the answer in. And don't forget the unit. If you forget that unit, you end up losing half a mark every time. 2 decimal places, 10.41 metres per second. So that's is that a reasonable answer for a person running a 100 metre race? Yeah. They're fast, no doubt. There'd be students here who could probably come close to that. 10.41 metres per second. That's a reasonable answer. If my answer was 1.41 seconds, something should go off in my brain. Hang on, that doesn't seem right. If my answer was 100 seconds, again, something in my brain should go, oh wait, that's not a great answer. Let's check to make sure I haven't done something silly when I transcribe the numbers. That's how you do your problems. Do the next one. What is Ben's displacement if he runs 8.1 metres per second for 7.5 seconds? Write that question down in your notes and then do the complete working out the way we did just then. I'll give you a generous 2 minutes. Oh, and while you're doing that, I'll mark the roll. If you don't have a calculator, you may use your phone this one time. Or your tablet, that's good too. Okay, give you another 30 seconds. Has everyone got the equation? The right equation? What are we trying to find in this question?
Displacement.
Displacement, which is an x. We want x. So, what's the formula to find x?
V times T.
V times T. Great. So, if you haven't gotten that far, that's where you would need to be. V times T. Okay, or just Vt as well. So, what's his velocity? 8.1 metres per second. Meters. Now, we can go metres per second, or I'll show you a different way of doing it. 8.1 metres per second, and what's his time? 7.5 seconds. Now, what's 8.1 times 7.5? 60.75 metres. Now, let's do this equation again. This is 8.1 metres per second. Okay? The -1 designates the seconds down the bottom, multiplied by 7.5 seconds. And I just put it over 1, just so it looks even. That's not a 5, that's a seconds unit, yes? Now, so what's 8.1 times 7.5? 60.75. Seconds on the bottom, seconds up the top, they can cancel out. What's the only unit I'm left with? Metres. And so, if you, by carefully laying things out, the unit that you are left with at the end should be the correct unit for whatever you're trying to determine. If you mislay out the equation, where the units end up can tell you if you've made a mistake or not. Okay, but there we go. I hope everyone had a well, certainly was successful, or at least had a reasonable attempt. Here's another one. Now, maglev trains move at over 500 kilometres per hour. How many metres would a train cover in 1 second? Wow, what an easy question. If it was travelling 506 kilometres per hour. And apropos of nothing, I've provided this. If you wanted to do a conversion from metres per second to kilometres per hour, multiply by 3.6. If you want to do kilometres per hour to metres per second, divide by 3.6. I don't know why I'm just putting that there. I'll give you 2 minutes to try and solve that equation. It should be a walk in the park, hopefully. You're only multiplying by 1. So work it out the same way, show full working. What equation, what are we trying to find? How many metres if the question is a meters question, what are we trying to find? Displacement. Yep. And so that tells you what formula we need to use, hopefully. And you'll go from there. Is anyone in units hell at the moment?
Do you just divide by a bunch of... Oh, okay. Yeah. Yeah, by frequency.
That's a long way in one of the triangle.
Yes. How far did you get?
140 minutes.
That's that right, yeah.
On the triangle, so is it...
That is the triangle for those formulas.
All of them?
Yep, for that one, yep. Okay, so what's the formula we need to use? Start there. X is equal to Vt, okay, which means velocity multiplied by time. However, we have a bit of a problem. The time is in seconds and the velocity is in hours. Can you perform calculations when you have units that don't match each other? No. Don't do that. You'll get into trouble. You end up with an answer, 506 kilometres per hour per second, which is nonsensical. Okay, so how do I get from 506 kilometres, how do I get rid of that hours and get it into seconds? Kilometres per hour, metres per second, divide by 3.6. What's 506 divided by 3.6? 140.056, which is sort of 06-ish. Okay? Now, so our velocity, and that is metres per second. Our velocity is 140.06 metres per second multiplied by 1 second, and so we end up with 140.06 metres is the distance covered. So that train is moving, okay, at a considerable clip. And the lesson there is when you're doing these sorts of things, you need to do a unit conversion so that that you're using comparable values and comparable units. Okay. Now we're effectively finished the slideshow. So well done if you've gotten those right.